All right, let's get right into it. Today, we're diving into a really fascinating investigation from a research group called Epoch AI. These are folks who study the forces driving artificial intelligence and try to predict its impact on our world. And they've set out to answer a massive question. Is AI's insane growth about to slam into a fundamental wall? The whole story really kicks off with this one number, 4x. That's the approximate growth rate every single year of the computing power we use to train the biggest AI models. This relentless scaling is the engine behind everything. It's why AI is getting so incredibly powerful so fast. Now you might be thinking, okay, 4x, that sounds big, but just how big is it? Well, take a look at this. It's a growth rate that leaves other massive tech booms in the dust. I mean, we're talking faster than the mobile phone explosion, even faster than the race to sequence the entire human genome. We are completely in uncharted territory here. And this insane pace leads us to the central mystery, the big, scary question at the heart of this whole thing. Can this really keep going? Or are we, and the entire AI revolution, about to hit a wall and hit it hard? So to figure this out, Epoch AI basically put on their detective hats. They identified four main suspects, four potential party poopers that could grind this whole revolution to a halt. You've got the physical stuff, power and chips, and then you've got the more abstract stuff, data, and believe it or not, the actual speed limit of physics. So let's investigate each one. First up, let's tackle our two physical suspects. This is all about the real-world nuts and bolts. Can we actually build the machinery for this revolution fast enough? We're talking about the raw electricity to power these massive models and the specialized computer chips that do all the heavy lifting. Let's start with power. And wow, it is no secret that AI is incredibly thirsty for energy. These gigantic training runs don't just use a lot of electricity, they absolutely devour it. And that appetite is just growing exponentially. Get ready for this number. By 2030, if we stay on the current path, just one state-of-the-art AI training run is expected to need around 6 gigawatts of power. That is an absolutely mind-boggling amount of energy for a single computational project. And to put that in perspective, 6 gigawatts is more power than what's consumed by several large cities, all combined. We are not just talking about building another data center. We're talking about building energy infrastructure on a scale we have literally never seen before. So is that the deal breaker? Is that the wall? Well, according to Epoch's analysis, probably not. It's a monumental engineering challenge for sure, but it seems to be manageable. The solution is basically twofold. Build absolutely massive data center campuses, but also get clever and distribute the training across the entire country's power grid. All right, next suspect, the chips themselves. The AI models of the future aren't going to need thousands of GPUs. They're going to need tens of millions. And right now, the real tricky part isn't just making the silicon itself. It's this super complex final step called advanced packaging, which is basically how you fuse the chip's brain to its memory so they can talk to each other at unbelievable speeds. But here's the bottom line. Even though we need a ridiculous number of new chips, Epoch's research shows that the major chip makers are already planning for it. Their factory expansion plans look like they're actually on track to meet this insane demand by 2030. So, once again, a huge challenge, but one that looks solvable. Okay, so the physical roadblocks look tough, but probably not impossible. Now let's turn to our more abstract suspects. We're moving beyond concrete and wires and into the realm of information itself. We're talking about the data AI needs to learn, and this wild idea called the latency wall. First up, data. Here's the deal. The AI boom has been fueled by an all-you-can-eat buffet of the internet, just gobbling up every book, article, and website it could find. The problem? We might be reaching the bottom of the plate. We're using up high-quality human text faster than we're creating it. So, if the text buffet is closing, what's the solution? You change the menu. The future is multimodal. Think about the vast, untapped oceans of image, video, and audio data out there. By teaching AI to learn from all of it, Epoch figures we can kick this data shortage can way, way down the road. And that brings us to our final suspect. And honestly, this one is a bit of a mind bender. It's called the latency wall. And this isn't an engineering problem you can just throw more money at. Think of it more like a hard speed limit imposed on us by the laws of physics. So how does it work? Imagine you have to pass a message down a super long line of people. Each person adds a tiny, unavoidable delay. As the line gets longer, just like AI models get deeper with more layers, All those tiny delays stack up. Eventually, you hit a point where you just can't get the message from start to finish any faster. That's the latency wall. So, is this what finally stops us? According to Epoch's calculations, while this speed limit is absolutely real, we're probably not going to smack right into it before 2030. Turns out there are still a lot of other efficiencies to gain before this becomes our #1 problem. So there you have it. We've investigated our 4 suspects: power, chips, data, and latency. Now it's time to bring all the evidence together, look at the lineup, and deliver the final verdict. And the cool part is, Epoch didn't just guess. They ran the numbers. What this table shows is their estimate for how big of an AI model we could train by 2030 before each of these bottlenecks would stop us cold. And just remember, the lower the number here, the bigger and more immediate the threat. And when you visualize that data, the verdict becomes crystal clear. The latency wall and data scarcity, those seem to be problems for another day. The chip supply is a bit more of a concern. But the most pressing threat, the bottleneck that's most likely to get in our way first, is power availability. So the final verdict is in, and it's pretty stunning. Despite all these almost science fiction level challenges, Epoch's investigation concludes that the historical 4x scaling trend can probably continue uninterrupted right through 2030. The revolution is not scheduled to hit a wall just yet. But the story doesn't end there, because if we can keep scaling at this incredible pace, what does that actually mean for AI's impact on the world? This is where things get really interesting. This brings us to a powerful concept Epoch calls increasing returns, and it's what makes AI so different. See, you can spend a fortune to train one super powerful AI model, and then you can deploy 1,000,000 copies of it for basically nothing. This train once, deploy many idea means that more investment doesn't just create more AI workers, it makes every single one of them smarter, all at once. And that leaves us with one final thought-provoking question that gets to the very heart of all this. If we overcome these massive physical hurdles and continue scaling, what are the economic and societal consequences of a technology that doesn't just grow linearly, but potentially exponentially? What happens when doubling our effort truly does more than double the result?